In order to move, objects require the application of force. But a ball, when released in mid-air, falls down to the ground. Similar to the motion of the ball, all things on the earth fall down to the ground. A skydiver, a fruit from a tree, even a cannonball fired from a cannon. Is there any force that pulls things down to the earth? Scientists found out that two bodies left on their own with no external force get attracted towards each other. There is a force of attraction between any two things with mass. This force of attraction is called the force of gravitation, or gravitation. Sir Isaac Newton proposed that even the Earth exerts a gravitational pull on bodies close to it. In Earth's case particularly, the gravitational pull is called gravity. It is gravity that pulls things down to the Earth. If gravitational force exists between two bodies, then why don't the objects on Earth move towards each other? We now know that gravitation causes two bodies to be attracted to each other. Let us discuss the factors which determine the magnitude of this attractive force. The two spheres approach each other under their gravitational pull. Now, let's replace one of these spheres with a larger sphere. You can see that the smaller sphere is moving faster now. This is because the magnitude of the gravitational pull is larger. Let us compare and check again. More mass means that the magnitude of the gravitational force is larger. Now, let us find out if the distance between the bodies makes any difference. We place two bodies relatively close and observe their motion. Now, place the same spheres a little farther apart. Observe how this time the two spheres move slower than when they were placed together. See how the magnitude of the force is larger when the two bodies are closer. However, the force is smaller when they are far apart. Newton drew similar observations and proposed the universal law of gravitation. It states that any two bodies in the universe attract towards each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The proportionality sign in the equation can be removed by introducing a constant of proportionality. This constant is called the universal gravitational constant. Being the universal gravitational constant, g has a fixed value and well-defined units. We know force is expressed in newtons, mass in kilograms, and distance in meters. These form the units of g. The value of g has been found to be 6.67259 into 10 to the power of minus 11 newtons meter square per kilogram square. There were some very important conclusions and deductions made from the universal law of gravitation. Scientists concluded that the Earth revolves around the Sun under the Sun's gravitational pull. This was later extended to all the planets. The law also helped prove that the Moon revolves around the Earth under Earth's gravitational pull. One of the important things that the law explained was the phenomenon of tides. Tides are caused by the gravitational pull of the Moon over the oceanic waters on Earth. Did you know that the universe, our galaxy, the Sun, and even the Earth have formed because of gravity? In the early universe, matter spread out after the Big Bang. This matter came together through gravity and formed the millions of stars and other celestial objects we see today.